In this video, we will look at two examples of how to find the equation of a line when given only 2 points and nothing else. So when we look at example 3, we see that whatever line that we are working with, it goes to the points -3, 2 and 0, -1. Well, to write the equation of a line, we need to think about properties of a line that we've discussed. One of those main properties is the slope. You always need to know the slope of a line in order to write the equation of that line. And we know that if we're given 2 points, we can find the rate of change between them. So we can find the slope using these 2 points using our slope formula. So recall the slope formula is slope equals y2 minus y1 over x2 minus x1. And it's okay to reverse that, y1 minus y2 over x1 minus x2, as long as you're being consistent with the order. So if it helps you, label your points. And we can call the first point x1, y1 because it's the first ordered pair given, and the second point x2, y2 because it's the second ordered pair given. So if we take that information and put it into our equation, we're going to have the following. M equals, and let's get our fraction ready. Y2 is -1, so we have -1 minus y1 is +2. And in the denominator, x2 is 0 minus x1 is -3. I'll put that in parentheses to point out that I have minus negative in my denominator. And so in our next case then, we'll have m equals, our numerator is going to be -1 minus 2, which is -3. Denominator 0 minus -3, remember, means 0 plus 3. So we have +3 in our denominator, which is going to reduce to m equals -1. So then you might ask yourself, well, what are we supposed to do now? In reality, it's the exact same thing we did for the first two examples. The reason, you now know the slope, you know a point the line goes through, and that is exactly what example 1 and example 2 had given us. It gave us the slope and gave us a point. As soon as we knew that, we could substitute into point slope formula. So that is what we're going to do here. Now that we know the slope, we're going to use our point slope formula to find the equation of our line. So our formula, again, is y minus y1 equals m times x minus x1. M is our slope, which we just found. And remember, even though this says x1, y1, we define this as being any point on the line. So even though this point right here has the x1 and y1 written above it, this is also a point on our line, so we could use this point instead. But if you want to just go ahead and use this because it uses the exact same notation, that's fine. In reality, either one of these points is going to get us to the same result. So let's go ahead and substitute using this ordered pair. That is going to get us y minus y1 is +2 equals, our slope is after that, which we found is -1. And inside parentheses, we have x minus x1, which is -3. So I'm going to use parentheses for that to point out that I have minus negative. So we do need to distribute through the parentheses. However, a good thing to do would be, let's rewrite this equation without the minus negative. So when we do that, we will have x plus 3 inside the parentheses instead, which is going to make it a lot less confusing when we distribute by this -1, which is what we need to do next. So let's go ahead and distribute the -1 and see our equation. We will have y minus 2 equals -1 times x is -1x, and -1 times +3 will be -3, so we'll put -3 for that. And we have one step left. It is to add 2 to both sides of the equation. And when we add 2 to each side of our equation, we are going to get y equals -1x minus 1. Okay, so now we have the equation of the line in slope-intercept form. We know the slope is -1, and now we see the y-intercept is also -1. A couple things to note here. One of those is a coefficient of 1 is not very standard to put. So even though it is -1x, most commonly what you will see is just -x. What we need to know is that means that we have a coefficient of 1 there. So when we see -x, understanding that the numerical value understood here would be -1x. Something else to note is our y-intercept is -1. And recall that if you have a point on the y-axis, the coordinates always start with 0. So the y-intercept in this case would be located at 0, -1. Well, if we look carefully, we'll see that that point was actually given to us. And this is not something that happens a lot, but it's something to look for. You could be given the y-intercept and not know it. And in this case, we were. This point, this second point given, has coordinates of 0, -1. If you plot this, this point would be on the y-axis, meaning it's our y-intercept. So in reality, after we found the slope, we could have seen that this was our y-intercept and jumped straight down to this equation without any of this work. But also note that if you weren't thinking about that, the work still gets you to the correct result. Okay, so point slope formula, it's a blessing because it's going to lead us to those conclusions. Okay, so let's try this with another example. We have a line that's going to pass through 2 points just like it did before. So let's go ahead and give this a try. We do need to know our slope in order to find the equation. So let's start there. Our slope is m equals y2 minus y1 over x2 minus x1. That's our slope formula. Let's go ahead and substitute then using our ordered pairs. And so if needed, label your ordered pairs as x1, y1, x2, y2. And then in our slope formula, we can substitute those values. Y2 is 8 minus y1, which is also 8. The denominator, we have x2, which is 3, minus x1, which is -6. And I'll use parentheses so I clearly see there's a minus negative. And in this slope here, it looks like we're going to get a result that involves 0 in our numerator. So we have m equals 0 over 3 minus -6 means 3 plus 6. So we get 0 over 9, but that's rather irrelevant. It doesn't matter how high of a value or low of a value that's in that denominator. As long as it's not 0, 0 divided by any number is going to be a final result of just 0. So we have an equation of m equals 0, or a slope of m equals 0. Okay, so we have a slope. It's equal to a value. We know a couple points that the line goes through, just like we have been doing. If you know the slope and you know a point on your line, we can use point slope form to find the equation of our line. So just like before, let's work with this equation and let's substitute in the correct spot. So we have our slope. We have a point on the line. Again, you can use either point at this time. Even though this has subscript 1s, it's the same as using your subscript 2 values. But if you want to stick with the subscript 1s to be consistent, that's fine. So let's go ahead and give this another try. Let's go ahead and substitute, and we're going to have y minus y1 is positive 8 equals m is 0 times x minus x1 is -6. So I'm going to use parentheses there so I clearly see there's a minus negative that I need to take care of. And just like before, let's go ahead and simplify inside these parentheses, change this minus negative to a plus. And that's what I've done here. I have our equation ready to go. To distribute, we have x plus 6 inside. We're going to multiply by 0. Let's see how that works for us. When we distribute on the right side, the left side will still say y minus 8 equals 0 times x, that'd be 0x, and 0 times 6 would be 0, which are not things we normally write, but let's go ahead and leave them for now. And then on the left side, we need to cancel the -8, so we will add 8 to both sides, which will get us a result of y equals 0x plus 8. Okay, so there's our slope-intercept form. Our slope is 0, our y-intercept is 8. We could simplify that though. 0x means 0 times x, and we know that 0 times anything should result in 0. So in other words, this term here is not needed. So let's go ahead and write this equation without the 0x. And so we'll have y equals, it's a plus 8, which means positive 8, and we can just put an 8 there, and it's understood to be positive. And even though the x is missing, we're actually finished. So this is the equation of a line, but it's the equation of a special line. It only uses the letter y, and that is how we write the equation of horizontal lines. And with a horizontal line, the y value is always the same. So for this horizontal line, every point on the line has a y value of 8. So actually, we could have saved ourselves some work on this one too. If you remember that horizontal lines have a slope of 0, we could have recognized that from the beginning. As soon as we knew the slope was 0, we could have realized this is going to be a horizontal line, and horizontal lines are written as y equals a number. And to know what y is going to equal, we could have looked at our points and seen that both points given had a y value of 8. So all points on the line will have a y value of 8, meaning for us, the equation of the horizontal line should have been y equals 8. But again, point slope formula is kind of nice because it will still get you to the end result, even if we don't go through thinking of all these processes. But doesn't mean we shouldn't try thinking occasionally to see if we can catch on to some of these nuances.